History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello and welcome to Tiered Storage for AI Workloads, part of the Supermicro Open Storage Summit. I'm Rob Strechay, Managing Director and Principal Analyst. The AI revolution is not just transforming how business operate, it's reshaping the very foundation of enterprise infrastructure. And nowhere is the impact more profound than the world of data storage. As artificial intelligence models become larger, more complex, more deeply embedded into enterprise workflows, the demands placed on storage systems are intensifying at an unprecedented pace. From training massive multimodal models to serving billions of low-latency inference requests daily, AI workloads require more than just capacity. They demand performance, efficiency, flexibility, and intelligent orchestration across hybrid environments. The result is a dramatic shift in how storage is designed, deployed, and consumed. Next-generation storage solutions are being purpose-built to meet the demands of AI, capable of supporting high-throughput data pipelines, GPU-accelerated compute clusters, and evolving needs of model-centric application architectures. Enterprises are no longer thinking in terms of petabytes, they're planning for exabytes. And increasingly, they're doing so across a mix of on-premise, edge, and cloud environments. This surge in demand is being driven in part by the explosion of generative AI, which creates staggering volumes of data, text, images, code, video, and requires real-time access to massive training sets. But it's also being shaped by a broader industry pivot, a growing emphasis on inference over training. As pre-trained models move into production, businesses are now optimizing their infrastructure not just for experimentation, but for scale, reliability, responsiveness in live environments. Inference is rapidly becoming the dominant AI workload, and it's shifting the center of gravity in the storage world. Meanwhile, vendors are racing to deliver storage architectures that can keep up, whether it's ultra-low latency NVMe fabrics, feeding inference engines, hyper-converged platforms tuned for AI workflows, or intelligent data placement technologies that anticipate and adapt to dynamic usage patterns. The pace of innovation is accelerating. At the same time, the sustainability imperative looms large, driving new approaches to energy efficiency, workloads distribution, and environmental impact mitigation. These challenges are not incremental, they're transformative, and they're giving rise to a new set of market dynamics as traditional infrastructure leaders and born-in-the-cloud disruptors alike compete to define the future of AI-ready storage. For hyperscalers and semiconductor giants to enterprise IT mainstays, everyone is rethinking their role in the new ecosystem. In today's conversation, we'll dig into the heart of the convergence, exploring how AI is reshaping the future of storage, what enterprises need to consider as they scale their AI operations, and how most forward-looking vendors are building for what's next. We'll talk about inference, data locality, sustainability, and new architecture of intelligence, because in the age of AI, storage is no longer a back-end function, it's a strategic driver of innovation, performance, and competitive advantage. And I'd love to welcome in my panel now. This is going to be really exciting stuff to dig into. Starting off with John Kim from NVIDIA, Kevin Tubbs from Weka, Giorgio Regini from Scality, Anders Graham from Kioxia, and we have Alan Liu from Supermicro. Welcome on board, everybody. So first off, I think what I would love to do is kind of get the impression from the panel of what your companies see as we look at tiered storage and as we dig into how this is transforming the actual infrastructure of AI. So John, I think we're going to start with you.
Great, Rob. Let me go ahead and start out by talking about some of the tiers of storage that we see for training and inference in the world of AI. So first, in AI training, this is creating the models that we see running AI, doing queries, things like ChatGPT and other models. And so typically with these models, you start out with a data lake. You have a lot of data out there, and this is usually on hard drive. Could be a mix of hard drive and flash, mostly hard drive, and it could be file or object storage. And the key is it's very large, and the performance has to be good, but doesn't have to be great. When you prepare the data for training, you move this onto some fast file storage. And again, it could be typically file, could be object, but it usually needs to be flash. It has to deliver very fast read performance because the GPU clusters for the training are going to read data from this storage over and over and over again. And then during the training, you need to have what we call checkpoints. And what happens is the checkpoints are a way to save the progress of the training. In case something bad happens, you can restart from the last checkpoint instead of restarting the whole training job. And these training jobs can run for months, so the checkpoints are very important. These checkpoints have to have very fast write and read performance. It's mostly write performance, but occasionally if something goes wrong, you're reading that data back. And again, that's traditionally file, but these days, some customers are now implementing that on object storage, but it's all flash. So again, one thing that's changing is as models get bigger and GPU clusters get bigger, these checkpoints are getting bigger, and they're happening more often. So the larger the cluster, the more often you have to do these checkpoints, and probably the more often you have to restore a checkpoint. So that's the key for the training. You have a mix of disk and flash, and you have a mix of read performance for the actual training data, but then read and write, mostly write for the checkpoints. When we get to inference, it's an evolving story. The traditional story about AI inference is you don't need storage. The whole model loads into memory. You ask one question, you get one answer. Everything's in memory. There is no storage. That's the old way of thinking about inference. Old meaning 18 months ago. Today with inference, it turns out there are two things that are driving the need for storage. The first is what we call RAG. That's a retrieval augmented generation. That means that the query can go into a semantic search and it can retrieve related documents, real-time documents that could be from just a few hours ago. And those documents go into the large language model as part of the query and then can come out as part of the answer as well. So it makes those large language models more relevant, more up-to-date, less likely to hallucinate, and typically more accurate. The other thing that drives the need for storage in AI inference is KV cache. So it turns out that as the queries get longer, if you have a reasoning model, if you have agentic AI, if you're using RAG, the context or the input sequence length gets longer and longer and longer. And it takes more and more time to compute this. So in many cases, it turns out you want to store that, what we call the KV cache, from the query and the context documents, and then be able to reload it if someone asks the same question or a similar question that uses the same context or same documents. In that case, you need very fast flash storage to store that, because you need to store it and then you can retrieve that KV cache instead of recalculating it. So that's the basic, those things are driving the need for flash, and we see a hierarchy here that you have from memory, you have HBM memory on the GPU, then you have CPU memory, you have local flash, networked flash, and then you have networked hard drives. And each one can store different aspects of inference. The KV cache can go all the way from HBM on this GPU, all the way down to networked flash, but then also the query history, and typically, or log files, a history of all the queries in the model used for future retraining or training future models tends to be saved on hard drive and in object storage. So that, in short, those are some of the tiers of storage that we see for AI training and AI inference.
That's great. I think when we start to look at it, and Kevin will really kind of dive in with Weka here and understand where you see things going as well, because you guys come at it from a little bit different perspective than NVIDIA. So let's hear what you have to say.
Oh, absolutely. So one of the key things that John talked about is actually going on. AI is evolving fast. So we talked about the last year, or the last week in AI has been the longest year of my life type of things we've seen out there. But what we've seen is this transition from training to large language models, now going to reasoning, as John mentioned out, to agents. And what we've seen is that flip from how we built for training to what needs to be done for new technology. And the key thing here is, as AI evolves fast, how do you future-proof? How do you make technology stack decisions that allow you to handle the workloads today, but also be built to leverage the technologies intelligently as we move forward? So one of the key things from that is putting a different type of pressure on what you must do with your data, and the data is the most important part of how you leverage that AI. There's different types of compute, different types of networking, different types of storage, but it all drives on that data and access to that data. So some of the key challenges are real-time responsiveness. There's an explosive growth in data. So you need to be able to keep up with that. So you need to be able to do things from gigabyte, terabyte, petabyte, all the way to exabyte scale. And then one of the important things about the workloads is they're unpredictable. What we're doing now and what we knew 18 months ago is not what we know now. So we need to make sure you make the right decisions up front. And data decisions, data architectures are very important to talk about up front so that you can evolve and change with the entire stack. So for us, that kind of built us to build a product and evolve a product. So we have our product, which is called Neural Mesh by Weka. And the key thing here, it's storage that evolved. We built it in a certain way for modern AI workloads and high-performance computing workloads, but we implemented it in a way to make sure that we could scale it with the size of the problem, but also with the innovation that we're seeing in AI. And the key thing to that is we're software-defined, and you can think of it as software-defined fabric, where we are a technology that allows you to connect the AI compute, the network, and the actual data, and figure out how to manage and balance those in a way that can scale with the problem. And the key part of that is to be a service-oriented and microarchitecture capability so that you can be resilient, fault-tolerant, but most importantly, scale and move from on-prem to cloud, out to edge, and really develop that technology, because where AI is going is wherever the data is and wherever the business outcome requires it. So there's a lot of portability that's required there. So for us, traditional deployment consists of the compute infrastructure, where the client, and that has a multitude of use cases and workloads and interfaces and protocols. So you need to be able to deliver that. And then our software, Neural Mesh, sits on top of commodity hardware, any x86, also ARM, and we have some examples here of running on Grace Hopper type of infrastructures. But key thing here is software defined, being able to run on different architectures, run them on-prem and in the cloud. And then the other part of it is being able to, from a software perspective, handle that data from the top of the hierarchy, where you're dealing with memory and GPU, all the way down to exabyte scale, which may end up being on hard drives and object storage. So being able to tier through those is kind of what our big picture is able to look for. And then the key thing here is we were engineered to really amplify model training, because that's where we were in our AI journey. And we're able to do a lot of things to speed that up, make it more efficient. But in the same code base, in the same evolving design, we've also been able to innovate and adapt to the emerging needs of inferencing, and been able to do faster time to token and faster pre-filling. And we think that that's going to be the end of the journey to make sure that we can deliver this across the entire AI spectrum.
Yeah, I think that makes a lot of sense as you look at that. And I think, again, as you were talking about that and how you're serving that out as files and being able to, manage a lot of data across there, it becomes super important, like you said, all the way out to edge, because when we look at it, inference is not going to just live in the data center. It is going to be distributed. And I know NVIDIA has some tech there we'll probably get into a little bit later, but Giorgio, Scality, help us understand where object comes to play with all of this, because I think it's definitely part of the mix.
Thank you, Rob. Sounds good. And I'm going to build on what John and Kevin said. I think it's all aligned. So Scality, we are a software-defined object storage company. We go after large-scale deployment. Think about petabytes to exabytes, multiple exabytes customer. We go after financial services, government service providers. They all have AI as their priority, right? And we do public, private clouds. We also do a backup and immutable backup security, and AI data lake is a big thing for us. But as you can see, AI is evolving, and object store is more than data lakes today. So if you look at how we see things in terms of very high level, you see two tiers. There's all the high performance part, all flash, as John said. And we have the capacity part, which is a mix of flash and drives, hybrid, we call it this way. In the pipeline of AI, you have the data collection, filtering, cleansing, and that uses S3 protocol for us, object. It requires good performance, but not top-of-the-line performance. What is important is capacity, multiple data center support, security, because this is your data you're talking about. Then on the performance side, extreme performance, low latency, less than a millisecond. So that's our Ring XP product for extreme performance. There's going to be training, fine-tuning, inferencing. Then as you move into the, if I want to take a look at the entire kind of build-up of tiers, you have the drives, the main capacity. You have a flash, which is going to be less capacity, but still you can go to hundreds of petabytes if you wanted to. Then you have a tape. People forget about cold storage. And it could also be in the cloud, right? But it's part of the tiers of storage. And then you have the very, very high performance. So for us, object meaning GPU direct support with NVIDIA, things that we're working on with them. And all of this makes all your different tiers, and they all could be object. We work a lot with Weka. And when we do, Weka acts as the tier 0 and tier 1. Doing the GPU direct connection and doing the file interfaces and tiering into our different Scality tiers in the backend. Joint customer of Supermicro, Weka, and Scality. It's Yukon, and it's an example of everything we said. It's AI-based for genomics, and they actually do Weka as a front end, Scality for 90% of the capacity. So if they need more capacity, it's going to go into the object store. And Weka is going to be here for the high performance. And they also tier to the cloud, and they tier to Azure. So they have the entire spectrum of high performance, the main capacity, and the archive into the cloud.
Yeah, and I think that's critical is that it's, and I think, Kevin, you talked about it as well, it's around putting the architecture in place, and I think that's what we hope that people will get out of this session is that understanding where they're going and how to start thinking about architecting the next, journey in storage for them, especially from a tiering perspective. So, Anders, Kioxia, help us understand where you guys play in this and how you help drive this innovation as well.
Yeah, thank you, Rob. My name is Anders Graham, Senior Director of Marketing and Business Development with Kioxia. So, Kioxia is a leading worldwide supplier of flash memory and storage. We initially were part of Toshiba, spun out, renamed as Kioxia in 2019. We own some of the world's largest fabs in Japan, make both memory and SSD technology. So SSDs, which is my focus, that's where we're really seeing a lot of growth due to AI. And there's really two key areas to focus on. The first one is high performance. So we're seeing the need for higher throughput, particularly in some of these areas of the AI lifecycle, especially on the training and the inference side. So there we're seeing a lot of the PCIe 5.0 SSDs really become kind of ubiquitous for their higher throughput. Some of the form factor updates are becoming more common now in the market. So E3.S, for example, is something that was built just to be a more efficient flash device. It's just 2.5 inches, so that's really starting to grow in those areas. Also, E1.S is now being used in a lot of the NVIDIA reference architectures for near storage, near GPU storage. So that's becoming more common. But PCIe 5.0 is really the trend there, and with Kioxia, we have our CD8P drives today, and our next-gen drives coming out soon, CD9P. Same thing with our enterprise. We have our CM7 drives for the highest throughput, and CM9 drives coming out soon with our BiCS8 flash to replace the CM7. On the E1.S side, we have the XT8 product as well. So The other piece is the capacity. So we've talked about the need for high capacity on the AI, data ingest phase, these huge data lakes that we're dealing with. So there's been a lot of innovation in that space. We're coming out with a product called the LC9, and that uses our BiCS8 technology as well, our next-gen flash. And typically, I don't talk too much about the underlying flash technology. 3D flash has become ubiquitous in the market. It's commonplace. But the one issue that we've seen with 3D NAND is that as we scale the layer count, it's also scaling the CapEx, which is problematic. So it's becoming more and more expensive to develop higher layers. So with the BiCS8, Kioxia came up with something called CBA technology, which is CMOS bonded directly to array. And that enables a couple things. The first thing is that it enables us to eliminate some of the peripheral, the circuitry in the peripheral, which enables us to do a lateral shrink, which makes it so we have a more efficient NAND product. And so what we can do is have higher densities with the same layer counts. So that's key, and that will help reduce our CapEx, and that's really what's driving the higher capacity drives. The other piece is we can separate the CMOS from the cell array, and that actually enables us to apply the optimal thermals to each, which can help us with power efficiency and also increase the performance. So we're seeing 30% higher performance now at the same power. So that's a big difference. And just to kind of button that up with the high capacity play, we have a 2 terabit QLC die now with BiCS8. And so with a 2 terabit die, you can have a 16 die stack that's 4 terabytes in a single package. And with 32 packages on a PCB, that's how you get to your 128 terabyte drives. And so this is now a very easy way for Kioxia and others to get to that capacity level. We also believe that there's a fairly easy path to getting to a 32 die stack, which will get us to 256 terabyte and even higher in future generations. So once you get to that level of flash density, then the ROI for moving from disk to flash really does come into play and start to make sense. So those are just a few of the ways that we're trying to help impact AI and help grow AI.
Yeah, I think that's a great way to think about it, and we'll kind of bring Alan in on this in a second here, that really more in the same package, in the same footprint, especially when you look at the environmentals, like you were talking about the power and the KV cache stuff, or the key value cache that John was talking about up front, and how that gets managed around AI is really important. But Alan, kind of bring us home on how you bring all of this wonderful technology to market with Supermicro.
Okay, thanks, Rob. In past 12 months, the explosive growth of AI workload has brought a huge challenge to AI infrastructure and the data center. The demanding on more powerful compute and high performance storage, fast and low latency network, as well as the bigger size of the data center get much higher. Supermicro has been working very hard with our partners to provide optimized end-to-end solutions to address this market need along the entire data path. Supermicro just released a new data center building framework. It's named the Data Center Building Block Solution, DCBBS. It is a fully integrated, balanced, designed data center building solution. It has comprehensive elements for data center building, including rack level and storage level building blocks that include compute, storage, network, as well as the environment blocks like thermal management and liquid cooling stuff. Also, it includes the design services and the professional services. Our AI infrastructure architecture is with performance, capacity, scalability, and cost effectiveness in mind. In the application tier, we have Supermicro AI servers that fully utilize NVIDIA AI products like HGX series, BG series and NVL series. We also, by the way, we also have a Grace CPU-based server. That is our demo unit. And as well, we have a Bluefield 3 based storage system that is JBOF. Supermicro products work with NVIDIA network equipments seamlessly. We support CX series and Spectrum switches for InfiniBand and Ethernet. In the storage layer, that is a tiered storage, just like Kevin just mentioned, Weka is managing the data platform. It runs on Supermicro petascale all-flash storage servers. On the tier side, Weka also coordinate with object storage like Scality for the capacity tier and with the cost-effective in mind. And there are also NCP certified reference architectures that customer can purchase and deploy quickly with a guaranteed performance and quality. In the whole architecture, SSD plays a very important role. Kioxia SSD enabled high capacity and high performance for the media, just like Anders mentioned. The whole idea is that to provide the customer a quick and easy way to build large-scale AI infrastructure with ready-to-use products. It is easy to purchase, just a very few SKUs from a single vendor. For example, we build XAI closest with 6,144 HGX systems in 122 days. This is a huge benefit for customer. Thanks, Rob.
Definitely. I think we'll take a down another level to kind of help people understand really what's going on underneath, because I think some of the things that have been brought up is different storage for different sizes of organizations going up. But the one thing that we do know is that, hey, storage is going to continue to grow, and that really what we're going to see is that there's a number of organizations that are trying to get into things like RAG. So John, why don't you kick us off here on the question and answer side with the fact that, you know, you mentioned RAG, and it's people might not understand exactly what that does to the infrastructure and how it really needs to flow, and you guys kind of sit at that data flow layer. So.
Yeah, Rob, absolutely. So I briefly mentioned RAG is one of the two big drivers of the need for storage in inference. And RAG means that, well, you know, traditionally with inference, you have a large language model. It was trained on all this great data, but it was trained at some point in time, 3 months ago, 6 months ago, 1 year ago. So if you use that large language model by itself, when it answers questions, it can really only draw upon the most recent data that was used in the training. RAG allows you to import and embed and index additional documents, enterprise content, web content, legal filings, financial filings, stock market data, PDFs. You can take all this data. You have this embedding workflow, which is shown on this slide. Uses a lot of NVIDIA components and also relies on storage such as Weka for file storage, Scality for object storage, and a lot of flash from vendors like Kioxia. And it takes these documents, it indexes them, and allows you to do a similarity search. So RAG unlocks the value or the information in these enterprise documents and web content, and it can be content from a few minutes ago. And so this content is then put into the large language model with the query. And the most relevant content is taken from the RAG database, and you have there's a vector database that does similarity search, and it's put into the query into the large language model, and it makes the answers more relevant, more accurate, but it also drives the need for storage. So as Alan mentioned, when people are doing RAG, they typically want systems built on an NVIDIA reference architecture, which we call MGX, HGX, or NVL. Supermicro makes versions of all of these. And for the documents, they typically want file or object storage. or both. And then for the vector database, they need very fast flash storage because it's something that is used to index and retrieve those documents. So essentially, RAG unlocks the value of the content, but it drives the need for tiered storage for AI inference.
Yeah, I think that's one of the things that as people look at inference and RAG, and as you go towards agentic, which again could have all of these components plus traditional AI or ML and other types of tooling. But let's kind of jump a little bit deeper. Kevin, when we're talking about RAG and RAG pipelines and really the challenges of AI, I want to kind of help us understand what's going on with, again, in those places where you're seeing all of the RAG and the different efficiencies that need to be gained and overcome.
Absolutely, Rob. So I think one of the things here, what we learned, inferencing flipped the script on the architecture. Where we talked about this, and John mentioned it earlier with the training, it was more meant on high GPU utilization, large, high throughput, long batch-oriented jobs, and maybe how do you checkpoint to be tolerant of those different type of data loads. But they aren't as real-time and aren't as latency sensitive. The biggest thing when we flip to inference is low latency. How long you wait to that first token, and to your point about agentic workflows, that creates what we call multi-turn. So it's going to actually create a lot more intermediate data and a lot of intermediate tokens in the meantime. So there's also this real-time need for bursty access to data, including the different levels of RAG. And those are one of the things that we realize that it's very important to understand and look at. And also you have to have an efficient use of that data and context and retrieval. So it's not just how much throughput, it's the low latency and the combination of those things. Another key thing to John mentioned earlier, when we started, everyone looked at what we think inferencing looks like. It's a user putting in a prompt, going to a GPU server with an LLM and getting an output. But that's not really the case. What it actually looks like is what John showed, that workflow of RAG interacting with vector databases, interacting with graph databases and other use cases. And what we're learning here is there's a lot of complexities in this that has to be understood from an architecture perspective and collaborated. And I think one of the bigger things that we've gotten out of it is it's now a collaboration between NVIDIA and Scality and Kioxia and Supermicro. And how do we solve this problem? Because it changes very dynamically and we have to work together and you have to test these things. So a lot of the software is actually in the AI enterprise from NVIDIA and NIMS, but they interact with so many third-party software, including our own. So we have to do a lot of collaboration, a lot of testing, a lot of tuning, and even on the inferencing side, integrating into the inference servers. We also lately have been participating more in open source because it's a community and ecosystem effort to get this capability out.
Yeah, I think that to me, that is part of it. It takes an ecosystem to actually deliver these solutions. And I'm going to shift over to Giorgio here for a second and kind of look at the fact that when I look at this, and I think it's more than just scaled out storage, but from an object perspective, you look at it and object is used for so many different things. What do you see as kind of the advantages of object for AI?
Yeah. So if you look at the developer point of view, right? So developers are smart, they're also very lazy. I can say that because I'm a developer as well. Yeah. And lazy means they want to automate everything, they don't want to do it by themselves. They also don't care about what's happening to your data, So if you look at you talk about the ecosystem. So there might be 1,000 open source tools that can do AI. They all have in common that they ask for a bucket somewhere. You need a bucket, an object bucket, and an access key and a secret key, and then they get going, right? So if you deliver object storage to them on-prem, they want the same simplicity. So the object, they can just set up a bucket automatically. They don't have to do anything manually next. And then they give a key and a password, and that's it. And now they can access these exabytes of storage. And they don't care if it's on flash, on drives, on tape. All the same API, all happens magically in the backend. We take care of transition, lifecycle policies, security, and all these things for them. So that's kind of simplified and make it look more like what they used to, which is they used to prototype in the cloud, and on-prem now is the same as the cloud.
Yeah, I think that to me is the simplicity, and we'll go to Anders next, but I think that when you start to look at the simplicity of how object, file, all work together with, again, SSDs, because I think, again, you need it for the efficiencies, the scale, and to get to the capacity from a perspective of how all of it comes together. When we start to look at all of this, Anders, again, it's one of these things that you start to look at how the enhancements of SSDs has really helped growing and drive AI, because without being able to keep the NVIDIA GPUs busy, AI just doesn't work. So kind of go into what those advancements are and how it's really helped drive AI.
Yeah, thank you, Rob. So let's talk about SSDs, in reference to the AI data processing lifecycle. And I think John already went through probably most of this already, so I'll keep it brief. But yeah, on the data ingestion side, right, you're seeing these extremely large data sets, these high cap drives that I was talking about earlier. They're really going to have an impact here because you can look at the rack level density, and you're going to have lower power per gigabyte at a system level. You're going to have lower power per IOP at a system level. And as data storage architects start to determine how to utilize these high cap drives in their infrastructure, I think it's going to make a big difference longer term. And so I think the high cap innovation is going to be a big piece. And then when we look at some of the other areas like AI training, as we discussed earlier, you don't want to leave those GPUs idling. So you need the highest throughput, right? That's where PCIe 5.0 drives today are having a big impact in these new form factors designed specifically for flash that give you more efficiency at the rack level. And there's certainly room for innovation in this space. And within the AI training, the checkpointing is also critical, right? When you're doing the training, you're only going to train certain segments of data at a time. You got to run checkpoints to determine how accurate the model is looking. You have to have extremely high throughput for the checkpointing operations to make sure there's no downtime there. And then moving to the inference stage, when we look at retrieval augmented generation, as mentioned earlier, latency, super critical in this area. So this is another area where all of these innovations that we're seeing on SSD and the performance on the latency side and on the capacity side are having a big impact just on the AI data processing lifecycle, and will really help grow AI, moving forward.
Yeah, I think we can all agree that it's really going to be how all of these building blocks come together, and there's not one piece that's more important than the other, because they all work together in concert. And again, it's one of these things. But Alan, I caught something that you said in your intro. You talked about, again, fully integrated and balanced solutions. What does that really mean from a Supermicro perspective? What does fully integrated and balanced mean? Because to me, that's really one of the keys that I think there could be.
Yeah. So when we talk about fully integrated, balanced design, these kind of words, that actually it includes a couple of factors, right? For the fully integrated, that means that your architecture must be having the unified systems. That means that the whole architecture, you cannot have silo in it. So that every component need to work with others, and you have to have a fully compatible, and the systems can work together. So this is factor number one. Number two is that you have to have end-to-end optimization. So that means that not only hardware, but also all the stacks in the architecture, they need to be fully optimized. So just like in our architecture, not only Supermicro stuff, we have NVIDIA, we have Weka, we have Scality, and also the key thing, SSDs. These need to work together perfectly. So, and also the number 3 factor is that you have to be scalable. Scalability is very important. So the design has to be modular. So that make the architecture scalable as the expected. When we talk about balanced design, that means that you have to have the resource optimization. So for the whole architecture, you cannot have overutilized part, and at the same time you have underutilized part. That's not the right one. So, and also for the power and liquid cooling management, they have to be balanced and they have to be efficient enough. So look at the Supermicro. We have leading liquid cooling technology. Today we have DLC2. That is the DLC stands for direct-to-chip liquid cooling. So yeah, we are the leader in that field. And for the last factor I want to mention here, not limited to these many, but I just want to mention is that you're supposed to have to consider the cost and performance the balance. So you don't want to build the system that it's good, but it's very, very expensive. So all these factors you need to put together. So look at Supermicro solution, all are there. So this is what I mean about this. Yeah.
No, I think that totally makes sense, and kind of going back to the underlying parts, because I think this hits a number of different pieces, is that really as we look at the entire system working together in concert, I think we're going to hit on something that I kind of brought up, but it's one of my favorite topics, I guess you could say, from this is really around KV cache, because I think to me it's such a smart way to be able to keep things running and really going. John, why don't you kind of help us understand the NVIDIA perspective on KV cache and how it really works here?
Rob, absolutely. So many people don't know that with inference, there are really 2 stages. So, people know I ask a question, I get an answer, but what happens is the GPUs first do what's called prefill, where they process the prompt, and then they do decode, where they generate the answer. And these 2 stages, first you finish the prefill, and then you do the decode, and they have slightly different needs on the GPU, and sometimes it makes sense to separate them onto different GPUs, known as disaggregation. In addition, it turns out that a lot of times the same question comes up again. People ask the same question about a company or about a new medical treatment or about a particular a stock price or a news event or about a piece of code. And the question is the same, or the context around the question is the same. So you can reuse, if you store it, you can store this KV cache around the question, around the prompt, and reuse it. And if it's a large prompt, it saves you a lot of time and compute power and energy compared to recalculating it every time. So that's what we call KV cache storage and reuse. And so in addition to, I said we talked about RAG, drives need for inference, and you mentioned at the beginning that there's people want to do AI inference at scale, and they want to do it efficiently, fast and efficient. So it turns out with KV cache, in many cases you can store it, you can reuse it, and it's faster than recalculating that prompt. The longer the prompt, or the bigger the context, the more documents you're putting into that prompt, the more time and money you save by reusing the KV cache. But it requires fast storage. It requires, and it can be fast file or object storage, but it has to be fast flash storage. And as Kevin and Giorgio and Anders mentioned, with inference, generally latency is key. So I talked about with training, throughput is the key metric. With latency, throughput's important, but on the inference side, with throughput's important, but latency is more important because you want to get that first time to token and then the maximum number of tokens per second. So NVIDIA is developing tools to make it easier to store and reuse KV cache across different types of storage, across memory and file and object storage. And so that, I think that's part of the current frontier of inference right now.
Yeah, and I think let's stick to this theme because I think there's a perspective from a Weka perspective that really ties in with this as well, because I think when, like you were saying, being tied up to the hip with NVIDIA and really helping, drive through a lot of these different things, KV cache and being able to get to that and utilize it, be it near or far across the network, makes a lot of sense. So Kevin, why don't you kind of help us understand the Weka perspective on KV cache as well?
No, absolutely. And I think this is a thing about innovation and being responsive to the new changes in AI. We've always been fast storage built for AI and working closely with NVIDIA. What we were able to do was create a new feature in our product called Weka Augmented Memory Grid. And basically what we realized was that it's about the tokens you receive from the input, as John said, and that you deliver to the customer in that output. So basically, you have this concept of a lightning fast token warehouse. So now it's, how do I get these things in and out? How do I answer prompts and do multi-turn, do reasoning, do agentic workflows as fast as possible at low latency? The other key part is this requires tight integration with the AI inferencing servers and engines. And this was a big collaboration between NVIDIA and Weka as well. So as they started developing new tools, we already leveraged GPU direct storage, or GDS, but as they developed tools that were highlighted, that were geared toward inferencing, we were able to innovate and develop right alongside of them. And that's where Augmented Memory Grid came in. And the key thing there is we're looking for radically improved tokenomics. So how do I deliver more tokens in the same
tokenomics.
Yes.
That's a new one on me. I'm going to steal that. That was great.
And to Alan's point, we want to be able to deliver this leveraging the technology that was already pre-designed and certified and reusing it in different ways. So you can also think of the Augmented Memory Grid as, how do I use Weka's neural mesh, and how do I reapply inferencing highly tuned on the same infrastructure? And that also requires flexibility. So for us, we have different ways to deliver neural mesh. We can deliver it in a dedicated, where you have a cluster that'll have Supermicro servers, including the Grace servers, driving NVMEs from Kioxia and things like that. Or you can have the actual compute AI servers with NVMEs inside of them. Because we're software defined and a software architecture, we can deploy in both of those ways. And we find that if it's already been deployed in a dedicated way, we can optimize that and deliver more tokens that way. Or, and a lot of times in your NCP designs, we found out that we can reuse that same NCP design, now geared toward inferencing, and deliver it in a converged matter, which we call Neural Mesh Axon, which we just launched earlier this week. So what do you get from that? Just multiple levels of innovation, but different ways to deliver it operationally. So as John mentioned, we got a reduced first time to token on the second turn, or multi-use and agentic workflows. You also get a simplified architecture for operations. So when we look at this, going back to the hierarchy that John talked about, we're taking that KV cache from the HBM layers, a gigabyte scale KV cache, going down into a single system where you're going to leverage the DRAM. That's a terabyte scale. But what we want to add is go through the network using Bluefield, using NVIDIA technology at low latency, and be able to deliver a petabyte scale KV cache. And not only do you get larger amounts and that scale automatically out to Scality to exascale, but you're also now able to move them from server to server because you have a network attached storage solution to it. So it also improves in a single server, but also across the entire fleet of the data center. And then lastly, that also gives you higher overall token throughput for that design, for that data center. And we think just that combination of different technologies would not be capable without an open approach and out a collaborative approach across a lot of different companies.
Yeah, we're hearing that a lot, and I think we'll jump over to Giorgio for kind of a question kind of building off of that, as you look out into the future and you see, what do you think is kind of the future of object storage when it comes to AI? Because I think, again, all of these pieces are critical, but you have a unique view of where this is going.
Thank you, Rob. Yeah, that's a very passionate topic for me. So you see, first of all, it's going to be performance. We talk about the different tiers. I think object, we move up tiers. To give you an anecdote, I have a very fast car, okay? A friend of mine was trying to convince me to race it. And I was like, hey, maybe, I don't know, yes, I'm going to do it. Then he says, first thing we do, we remove all the seats. I said, no, you're not going to do that. But that's how you get the best performance, right?
Right.
And Amazon showed us the same thing with S3 Express. So we take the S3 API, we move features, we move versioning, we move multi-geo, we move security. And now you get the best performance. So I think they didn't go far enough in some aspect. I don't like that they remove a lot of things that I would have kept. But I think there's a middle ground we can find, and there's a new kind of bucket that's going to come. So buckets that will be in a layout that makes sense for the GPUs to access directly. And how do we make it faster? The software stack, you remove it. And that's why you do NVMe over Fabric, so that you go directly from the GPU to the flash. That means the way we write data on the flash drive should be optimized for that. So we're working on this, and it's part of our Ring XP product. How do we optimize the layout of the data, remove the features you don't need, so you get the best performance? So that's one part. The other future of object is, as you see, there's a lot of people went to AI very quickly because we didn't want to lose out, but they forgot a few things. And so security, I think, is part of it. So you would see object being used more and more because of all the security aspect that comes from it. There's also these things like a vector database. So how come you have such high security on your bucket, but the vector database has a basic REST API with nothing else?
Yeah.
So it's going to be becoming part of the object store. So you will see more and more features that are outside of the object store become native object store API features, so that you get the same control, the same access tokens, the same kind of namespace.
That totally makes sense. And I think, again, when we start to look at how all of these come together, I think we're living in the first couple innings of AI and inference and RAG and going toward, agents are all the talk this year. We'll probably actually see them being much more real next year, like we did with inference, being this the year of inference, and bringing that together and really requiring new storage architectures. Anders, what do you think are some considerations that storage architectures should take into account because of AI?
Yeah, thanks, Rob. When we look at the SSDs and the choices that we have within the AI storage architectures, I just want to talk through some of the things that we're seeing and some of the decisions that are being made, and why. So, as far as the AI data ingestion area, what I mentioned earlier, you have these huge, extremely large data sets. It does make sense to go to the highest capacity drive, the 122 terabyte QLC, but not all the time. So sometimes we're still seeing the 30 terabyte TLC drives being used, for example, the CDAP that's available today. And part of the reason there is that has the 4K indirection unit. So depending on how your data sets are being managed, sometimes that drive can make more sense. With our CD9P BiCS8 drive that's coming out, that will actually have a TLC 60 terabyte with 4K as well. And then if you are able to go to the 16K IU indirection size, that's where we're seeing the move to the big QLC drives. And we are seeing, I think, a lot of the software stacks get rewritten. And longer term, I think we'll be on a path to move in that direction. But there are a variety of options, and so understanding which is suitable is gonna make sense.
You just made Giorgio extremely excited.
Exactly.
About that.
Yeah.
So this is
I want to buy one.
Yeah, and then if we look at AI training and checkpointing, and we talked a little bit about this earlier, so I won't have to get into too much detail, but on the AI training side of things, as I mentioned, you can't leave those GPUs idling. You need the really high throughput. So there we see the data center class drives. We also see enterprise class drives. It's the highest performance that you can get is what's really needed in this space, highest throughput that you can get. And so we sometimes see enterprise class. We also sometimes see 3 drive write per day. So for example, 15 terabyte seems to be a sweet spot for AI training. Sometimes we'll see 12.8 terabyte drives used, not necessarily for the endurance, but because you can get higher random write speeds when you do some of that over provisioning. So sometimes those drives are used. We also see E3.S growing in the training area and the checkpoint area. The reason for that is that you can use this sort of mid-capacity sweet spot, and there the E3.S drives are the most efficient from a rack level. For the AI data ingestion, those really high cap drives, the issue that you have is that when you move to E3.S, you do get more drives per system, but a 2.5-inch drive still has about 66% of the drive units per system, but a 2.5-inch drive has twice the capacity at the high end as an E3.S. So for those really high cap drives, 122, we still think 2.5-inch is going to be the predominant form factor when you go to the max cap. However, there's room for innovation in that space. The Open Compute platform, there are folks that are looking at new form factors, if you can believe it. But I think there is room even for another type of EDSFF form factor to maximize capacity. And then as you move down to the AI inference, that area, as we mentioned, latency is key. The really good latency that's available right now through the data center class drives, I think seems suitable from a cost perspective. But the one last thing I'll say is that the rooms where there are areas for innovation here, it's really the high capacity. I think we'll continue to see the capacities move up, the utilization of the larger indirection units, and then the really high throughput. I think there's room for innovation with even higher throughput drives, PCI 6.0, potentially even new innovations in this space. So in the next couple of years, it's something to keep an eye on, and I think it'll just get more exciting as the market continues to mature at an extremely rapid rate.
Absolutely. I think, again, when you start to look at all of these pieces coming together, it brings me back to Alan and Supermicro here. How do you look at this as bringing all of this together, all of these different tiers, all of these different technologies in an optimized way for customers?
Yeah, so to provide the best comprehensive solution for customer, as a supplier, I think that the partnership is very important. So Supermicro has been partnered with these vendors together for a long time, and we earn the trust from each other. So we have been working together for each other. From a Supermicro's perspective, we have a lot of resources to work with our partners from various levels, from research, engineering, production, even the business, that we move along all together as a virtual team. So Supermicro has been on the market for over 30 years. So we did create a very good and great reputation on the market. And the next thing I want to say is that we want to follow and keep the eye closely to the market. The customer needs, the market needs. Just like Anders just mentioned, that when we see the market trend for the next how many years, that where it goes, that we need to work together to make sure the customer needs is there, we can address it on the time. So for example, that today we see the AI workload is there. So the data grow explosively, and how to accommodate that from a storage perspective, from a computing perspective. So we have a tiered storage today, and how long time can we use that? So what's the next? We need to consider, and how to address the customer need. So I think this is a very important factor. Partners and customer needs are the key.
I think that's a great place to leave it. I think, again, everybody has brought a lot of information that's going to make people think about their storage architectures and how they look at tiering their storage into the future, because I think, again, the infrastructure is changing, and you need to have a local, a remote, and a different sets of tiers even in that remote that help bring AI to life. So thank you all for coming on board today. This has been really informative for me and hopefully for everybody else out there. And thank you for watching this episode, and we'll be right back with more from the Supermicro Open Storage Summit. Stay tuned.